Let's find the distance between these two skew lines in a cube with a side length of 3. There are several ways to do that, and we're gonna look at 3 different solutions. The first one is a classic solution where we just find the distance as the length of some perpendicular. But trying to construct and find the common perpendicular of these two lines isn't the best idea in this case. We're gonna do something else. Let's name this cube ABCD A1 B1 C1 D1, and let's draw AD1. We can see that AB C1 D1 is a rectangle, which means that BC1 and AD1 are parallel to each other. In fact, we can see that the whole plane AB1 D1 is parallel to BC1. So this plane is parallel to this line. Basically, here I'm just using the fact that one plane and only one may be passed through one of two skew lines and parallel to the other. On the diagram, we have two skew lines A and B, and two planes pi and sigma parallel to each other and the lines A and B. So the next step is to say that the distance between BC1 and AB1 is the same as the distance between the line BC1 and the plane AB1D1. In other words, the distance between two skew lines is the same as the distance between one of them and a plane passing through the other one. But since they're parallel to each other, the distance between the line and the plane is equal to the distance between any point on the line to a plane. Particularly, it is equal to the distance from the point B to the plane AB1D1. So now we're trying to find the distance from this point to this plane. And here we're going to use another interesting fact. We're going to use the fact that if a plane passes through the middle point of a segment, then the distance from the ends of the segment to this plane are equal. On this diagram, a plane passes through the midpoint C of a segment AB. So AC is equal to BC, which means that the distance from B to this plane is equal to the distance from A to this plane. So these two distances are equal. So in our case, instead of trying to find the distance from B to the plane AB1D1, I'll be finding the distance from A1 to the plane. And to do that, let's look at another diagram. The distance that we're looking for is an altitude of the pyramid AB1D1 A1. Its base is an isosceles triangle with side length 3 square roots of 2, and lateral ribs of the pyramid are equal to each other. So H is the center of the triangle AB1D1, which means that AH is a circumscribed circle radius, and AH equals 3 square roots of 2 divided by square root of 3. Then, using Pythagoras theorem in this triangle, we can find that A1H is equal to square root of AA1 squared minus AH squared. And if we do the math, then we get the answer square root of 3, which is the required distance between the lines. The second method of finding the distance between these two skew lines is to use Cartesian formulas. Let me remind you that in order to find the distance between a point x0, y0, z0 and a plane ax plus by plus cz plus d equals 0. We use the following formula. The absolute value of ax0 plus by0 plus cz0 plus d divided by the square root of sum of squares of a squared plus b squared plus c squared. Basically, we're just plugging the coordinates of the point into the equation of a plane. Then we find the modulus of that value and divide it by the length of the normal vector to the plane. First of all, we have to introduce coordinate axis. This is going to be z-axis, here's y-axis and x-axis. Then we need to find the coordinates of point B because we're going to calculate the distance from point B to that plane. We also need these coordinates. Point B1 is 3, 0, 3 and D1 is 0, 3, 3. Now we have to work out the equation of the plane in a given form. Since the plane passes through the origin, the constant term d equals 0. Since the plane passes through the point B1, we have 3a plus 0b plus 3c equals 0, which results in c equals minus a. And since the plane passes through 0, 3, 3, we have got 3b plus 3c equals 0, or b equals minus c, and since c equals minus a, we have b equals a. So the equation of that plane is ax plus by or ay plus cz or minus az equals 0. And if we divide it by a, we will have x plus y minus z equals 0. And that's the equation. Now, using that formula, we will have following for the distance. 3 plus 0 minus 0, I just plugged these coordinates into this equation. This is going to be equal to 3, so there's no need for absolute value sign. And we have to divide that by the length of the normal vector. And the normal vector has coordinates 1, 1, minus 1. So we have 1 squared plus 1 squared plus minus 1 squared, or 3 divided by square root of 3, or just square root of 3. And of course the answer is the same as in the previous method. And our final third method is an elegant volumes method. And in order to see how it applies to our problem, we have to rotate the cube. We are basically solving the same problem, but we're looking at it from a different angle of view. Let's look at this tetrahedron. We're going to concentrate on its edges A and B. Let's say that the distance between them is equal to D and the angle between them is phi. We can use this formula of the volume of this tetrahedron to find the distance between two edges of the tetrahedron, but we need to first find its volume. And this diagram should give you an idea of how to prove this formula. We're going to use this formula to find the volume of tetrahedron A1B, B1C. The volume is equal to 1/6 of the product of two skew edges, A1B times B1C, multiplied by the distance that we're looking for, multiplied by the sine of the angle between them. On the other hand, this is a tetrahedron with a base B, B1C, so its volume is 1/3 of the product of the altitude, or A1B1, and the area of its base. So we have 1/6 multiplied by 3 square roots of 2, by again 3 square roots of 2, by the distance, by the sine of 60 degrees. And the angle is clearly 60 degrees if you think of triangle A1DB. It's equilateral, so this angle is 60 degrees. On the other hand, this volume is 1/3 multiplied by 3, multiplied by 1/2 of 3 times 3, which is the area of this base, which is a right-angled triangle with a leg 3. And if we solve this equation, we have square root of 3 for the distance between the skew lines. Thank you for watching this video. I hope you learned something new.